Well, good morning, good afternoon, and good evening to everyone joining us here today. My name is Ruben Delgado, and I am one of the enrollment representatives from Coursera. Thank you so much for joining us for the Experience Data Science webinar, where you're going to have a chance to learn more with live course demos from Glover University professors. We're so excited about today's event, so I'll give you a few seconds to get settled in, and then we'll get started. Great. Today, we have the pleasure of being joined by 4 data science professors from top universities. Dr. Barber and Dr. Sexton join us from the University of Leeds. We have Dr. Babichenko, who joins us from the University of Pittsburgh, and Professor and Faculty Director Rachel Cox from the University of Colorado Boulder. Today, these distinguished educators join us as representatives from the universities, also as experts in data science and in their online degree programs they teach. I'd also like to take a second to introduce my co-host, Isabel Diaz. Isabel, feel free to come off mute and introduce yourself.
Hello, everyone. I'm Isabel, and I'm one of the enrollment representatives here in Coursera, and I'm very excited to be part of this event. So thank you for joining us.
Thanks, Isabel. Our university professors have a ton to show you today, so let's go ahead and get started. As a reminder, this session is going to be recorded and sent out afterwards. Throughout this session, you may also submit questions throughout the Q&A feature, as the chat feature is going to be turned off. We're going to do our best to answer your questions throughout, and also we're going to have a formal panel with our keynote speakers at the end of the presentation. Please note, if you're asking questions about a specific program, include that program in your questions so that we can better help you provide an answer. And as you might remember, you also submitted questions with your registration. At the end of the presentation, our professors are going to join a panel discussion. Well, they're going to address some of the questions that you have shared.
Great. So let's have a look at today's agenda. So we will begin with a brief discussion about data science, industry, and trends. And then we will have our professor demo lessons, and they will be presenting a demo lesson on one of the top skills that data scientists are using right now. So this is statistics, Python, and machine learning. Next, we will have some final information about online data science degrees hosted on Coursera. And finally, we will wrap up our session with a Q&A. And so please keep an eye on the chat. And throughout our session, we will be sharing some important links that you can use to learn more information about our programs, but also on how to get in touch with our enrollment representatives so that we can address any questions or concerns you might have.
All right, guys, before we jump in, we're going to have a quick survey for you. Are you considering a degree? I'll just go ahead and give you a couple minutes to respond to this survey. As you can see, it's popping up on your screen right now. All right, so what do we have coming in? We have that 35% of you said yes in the next 12 months, and that's great. Another 14% said yes, they want to start the degree within 24 months. We have about 38 who said, I've been thinking about it, but not sure. Hopefully through this presentation, we'll be able to tell you a little bit more about, why you should start sooner rather than later. All right, one more. If you've answered yes to the previous question, what, if anything, is stopping you from taking that leap and enrolling? And I'll give you a few seconds to look at those and vote in there. All right, so we have the results in. 45% said cost, 31% saying time commitment, and then we have other ones in there. Actually, the top 2 ones are very typical. It can definitely be tough to afford actually or have the time and tuition in higher education. In fact, Your answers are similar to some of the ones received from other learners. According to a 2024 NASA report, about 85% of adults who either dropped out or never enrolled in higher education said an important reason why they were not enrolling was because of the cost of that degree or credential program. To take it a step further, actually, our internal research shows that, or discovered that both cost and time commitments are two of the top barriers for our learners who they're considering a degree program.
Online degrees are actually best known for their flexibility and affordability. In fact, working professionals are the majority of online learners. So for those of you who are considering getting your degree but struggling to find the time, please keep in mind that 60% of online learners work full-time. And with the rate of acceptance for online degrees only growing each year, this is a flexible and affordable way you could level up your learning and advance your career. If cost is a concern, please keep in mind that most of the online degrees hosted on Coursera allow you for a pay-as-you-go basis. So, and many of them accept federal funding. You will also be interested to know that there are also options to apply for prior learning recognition, and this might help you to potentially save on tuition cost. So please visit our individual degree pages under the financing tab to learn more.
As an enrollment representative, one of the main problems that I often hear from learners is their inability to afford higher education. Many of these learners are really interested in pursuing a degree. As you can see on the screen, 80% of working adults are interested in going back to school. However, only 40% realized their employers offer tuition reimbursement. And when we take it a step further, only 2% of employees actually participate in this type of employee reimbursement. So for you, are you one of the 80% interested in the degree? Well, maybe a simple ask from your HR department might be the only thing standing in your way.
So I wanted to take a minute to address some of the frequently asked questions we often get about online degrees. So at Coursera, we offer online degrees in partnership with over 20 globally recognized universities. Most of them, the curriculum you will take for these degrees will be the same as the one of an on-campus version and will be taught by the same high caliber of faculty members. And today, we actually have the pleasure of meeting 4 of these renowned academics. Finally, when you graduate, your diploma will be issued by the university, and there will not be mention of the word Coursera or online. So all that said, let's transition into some information about data science industry.
Data scientists actually have a pretty healthy salary range. As of 2024, the US Bureau of Labor Statistics found the median salary to be over $112,000. Plus, the demand for these jobs is growing at a much faster rate than the average career at 36% over the next 10 years. You're also going to notice some of the key trends in the industry that employers are searching for. The good news is that we're going to cover some of these basic skills here in just a minute. Finally, before we transition into the demo lessons, we wanted to share a little bit more information about careers in the data science industry. We have data analysts, data scientists, machine learning engineers, and business analysts as just some of the careers in this industry. Others also include market researcher, data engineer, data ethics officer, robotics and AI engineer, and many more. Do these sound interesting to you? Well, a credential in this field might be the only thing standing in your way.
Okay, so thank you so much for staying with us during the first portion of our presentation. Up next, we have our professor demo lessons. So to kick things off, we will have Dr. Stuart Barber and Dr. Jenny Sexton from the University of Leeds to present a statistics demo lesson. So Dr. Stuart Barber is head of the Department of Statistics at the University of Leeds. His research focuses on wave-led methods and their application across fields like time series analysis, genomics, and spatial data. He also contributes to major research groups at the University of Leeds and has served on editorial board of the Journal of Applied Statistics and Series C of the Journal of the Royal Statistical Society. We are also joined by Dr. Jenny Sexton, who is a lecturer in data science at the University of Leeds. Dr. Sexton's background is in statistics and probability education. So, Dr. Barber and Dr. Sexton, whenever you are ready.
Great, thank you. So what we wanted to do today is to just take you through a few of the highlights from the linear modeling module that I work on and how that then links to the capstone project that my colleague Dr. Sexton works on. What we have here is a sequence of techniques that we can use for regression modeling, and I want to show you today a bit about how the theory and practice link together and about how we can have an increasingly complex sequence of models for increasingly complex types of data analysis. Next slide, please. So the starting point, or at least where we start this thread, is the idea of simple linear regression, where you use one variable as a predictor or an explanatory variable to try and explain or model how another variable behaves. And an example is, say, if you just look at the black dots on this plot, that's some data on how much gas is consumed to heat a house, and the horizontal axis is the average outside temperature. So as you might expect, as the temperature goes up, you use less gas to heat the house. And if you're prepared to assume a straight line relationship or linear relationship between these two variables, we work through the theory that tells you exactly which line you should choose as the best line. Now that starts out fairly straightforward, and we go on to think about, well, if you have more than one variable, how do you use several variables? In this case, there's actually two variables because there's a second group of data, the blue squares, and that's the house that's been insulated, whereas the black dots were houses that were uninsulated. We could have many more variables. We could have the challenge of trying to work out which variables to include in the model, which variables to leave out. And we go through all of that, and we work through a lot of practical examples to see how that works out in practice. You know, the next slide up, please. What we had there were some assumptions involved. One assumption was that there was a straight line relationship between the variables. Another one was that the outcome variable was essentially unrestricted. Often these assumptions might not work. For example, you might have what we can see here as a curved relationship. Also, in this case, what we're actually looking at is data about how changing the dosage of a pesticide affects the proportion of insects that are killed by that pesticide. And you can think of that as being a proportion, or you can think of that as being a probability, but either way, it's only possible for that variable to take values in a certain range. And a model that suggested, for example, a mortality of minus 15% would clearly not be any use to us, because it would be suggesting something that's completely impossible. So we look at, instead of simple linear models, we look at generalized linear models, and an example is given by this equation here. It's generalized in the sense that on the left-hand side, you don't just have the outcome variable, but you have some function of it, and that determines the shape of the curved relationship between the outcome and the inputs. A lot of the ideas about the theory of how to choose the right variables to include carries over, but we can now use it in a much wider range of situations. And you can see here, the black line gives you some actual data on how the dosage of pesticide affects mortality. And the dashed blue line is a model fitted using this particular form of generalized linear model, which clearly does better than a straight line relationship, but it's still not quite perfect. It overestimates in some places and underestimates in others. So we look at how to quantify that inaccuracy and what we can do about trying to improve it. Next slide, please. And then lastly, we look at a more complex form of model called an additive model, where instead of forcing a particular shape on the curve that we put through the data, we allow that curve to be adaptive and just react to whatever is in the data, whatever the data suggests. So here, the relationship between the adiposity or body fat in a whole group of patients relating to their age, you can see that it's much more complex than just a simple curve of the kind that we've saw in the previous example. Okay. Jenny, do you want to say how this then links into your project module?
Yeah, thank you very much. Next slide, please. So in the following 2 slides, I've created some regression models to examine the behaviour of pensioners who reported feeling loneliness in the English longitudinal study of ageing dataset. This dataset documents quality of life and health outcomes over the last 30 years. This first graph shows the relationship between alcohol consumption and expenditure on eating out, split by self-reported loneliness, with a linear regression line. Next slide. This logistic regression model can be used to predict the probability that a pensioner within the study reports experiencing loneliness. Here we can see that as alcohol consumption increases, each individual is on average less likely to experience loneliness. Why do you think this might be? Could it be related to being more social, or maybe taking medication that shouldn't be taken with alcohol? Do you think there might be other factors within the data that would better predict whether an old person would feel lonely? Once you've studied the mathematical foundations of regression models with Dr. Barber's module, the Capstone project offers you an opportunity to apply this knowledge to develop a model based on some real-world data. It's a hands-on, short project that gives you free rein to choose from a set of 4 project descriptions, design your own research question, and demonstrate the skills that you've learned during the rest of the programme. You could examine this data further if you chose, investigating factors that influence loneliness and their implications for government policies on social care. Or you could focus alternatively on topics such as modelling the flow of patients through a hospital, patterns in reported crimes, or even the consequences of climate change. Thank you.
Fascinating stuff. Thank you so much, Dr. Barber and Dr. Sexton. They join us today from the University of Leeds, representing their MSc in data science with a focus in statistics. The University of Leeds is actually ranked among the top 100 universities in the world and proudly offer this degree 100% online to all global learners. You're welcome to enroll with performance-based admission, or you can go with the traditional application pathway. Visit the degree page for more information. At just £15,000 of total tuition, this top degree will prepare you to develop your statistical expertise, professional skills in roles like data analyst, data analytics manager, data scientist, statistician, business analyst, and more. And finally, it is also possible that some of you already may have some credits towards this degree and not even know it. The Google Data Analytics Professional Certificate in Coursera is actually recognized as an accreditation of prior certificate learning, and this can be counted towards your degree. Eligibility requirements apply, so scan that QR code on your screen to meet with an enrollment team to learn more about it, or click in the link in the chat.
Up next, we have Dr. Dmitry Babichenko from the University of Pittsburgh to teach a demo lesson on Python. Dr. Babichenko is a clinical associate professor at Pitt School of Computing and Information, and he's a professor within the online Masters of Data Science program. His work focuses on virtual and augmented reality for education, medical training, and cultural preservation. Today, we have the pleasure of hearing a Python demo lesson from him. So, Dr. Babichenko, handling the screen, over to you.
Hi, everyone. Thank you so much for the introduction. So as you can imagine, working with augmented and virtual reality, we end up collecting a tremendous amount of data, and we have to figure out what to do with this data. So a lot of the data-related work that I do relates to essentially modeling user behavior in these complex systems. But also within the Masters of Data Science program, I teach two courses. I teach an introductory course on data-centric computing, and that course is designed primarily for students who wish to enter the program with no prior programming or data experience. So that course focuses on introducing students to core Python skills, because Python is probably one of the most common programming languages used in the data science field, and it's also a very well supported language. It has a lot of incredible, powerful libraries for machine learning and for data science. And pretty much all the courses in the Masters of Data Science program at Pitt are taught using Python. And then I also teach a course in data-oriented cloud computing, or I guess cloud computing for data scientists, where we kind of look at how to store, how to process, how to manage large amounts of data in distributed environments, and then how to actually build models from streaming data from those environments. But for those of you who have never worked with Python or have never done data science, no fear. We start with some very gentle introductions and very gentle examples. And usually, I've been teaching for a long time. I usually like to jump in and start sort of like with a more of a top-down approach, where we start with a problem, and then we learn about aspects of a programming language or aspects of statistical modeling through essentially breaking this problem down into smaller steps. And as someone who actually has an undergrad in history, a lot of problems that I pick tend to be from that domain. So one of the examples that I always give in my class is the story of the Federalist Papers. For those of you who are not familiar with that particular story, three political figures in American history, Alexander Hamilton, James Madison, and John Jay, published a bunch of essays, and for about 150 years, because they were published anonymously, for about 150 years, nobody knew who published what. And it wasn't until the 1960s where two professors, one from the University of Chicago and another one from Harvard, actually applied very, very simple analysis to the text. So they basically took known samples of writing from John Jay, from James Madison, Alexander Hamilton, and they figured, for example, that Madison used the word while, and John Jay used whilst. So two different spellings of one word. And by essentially making a bunch of graduate students miserable and having them count all those words by hand, they figured out who wrote what. So we use Jupyter Labs and Jupyter Notebooks on Pitt's cluster for most of our Python examples. And for all the courses, we provide a lot of annotated examples. So here's an example of how you could essentially learn about things like Python variables, how to work with text, how to work with lists. And this is all kind of given as part of a lecture, but on very specific examples, by taking tiny bits of sample text and then writing a very, very simple function that splits the sentences into individual words, and then iterates through those lists of words to identify instances of while versus whilst, and then come up with counts. And then if you essentially apply the same idea, the same function to a body of text, in this case, we have a very, very simple example of text from an unknown author, and you can count instances of certain words in that text. That kind of helps you identify who is the likeliest author. And we have a lot of examples like that where they seem very, very simple, but they're a gentle introduction to learning things like data structures in Python, how to iterate through data sets in Python, how to work with strings, and from tiny sentences to very large bodies of text. And it gives you these introductory skills that allow you moving forward to jump into more complicated problems. So to sort of like mirror an example that Dr. Barber and Dr. Sexton discussed in their presentation with linear regression, a very similar example given in Python would be, again, building on what you learned with very, very basic stuff in some of the previous examples and some of the previous work. Later example, you start jumping into statistical analysis, and you start jumping into very, very simple modeling. And this particular example it's baby steps. It's even simpler than the multivariable example that Dr. Barber introduced. But in this example, you are using only one variable as a predictor to predict another variable. So it doesn't get any simpler than that. And then we teach you how to use Python as a tool to essentially read a data set from either an Excel spreadsheet or a database or a streaming API. And then how to do some basic exploratory data analysis. So for example, for linear regression, you have to have some assumption of linearity. So you have to be able to look if the two variables are actually related to each other in a way that there's some type of linear relationship. There are also some statistical assumptions. So for simple linear regression, you kind of have to make an assumption that the data has reasonably normal distribution. So you can, we teach you how to visualize individual variables or clusters of variables to explore what shape the distribution has. And then finally, we discuss, if you build a model, how do you know that your model is working? There are problems of, the model exactly following the shape of the data, which means your model is overfitted, which means it'll be really, really good at making predictions on the data that it knows about, but it's going to be terrible at generalizing to the data that it doesn't know about. So we go through a set of steps where you basically take part of your data and use it to actually train your model, and then use the rest of the data that the model doesn't know about for validation. And then, you can actually build your model. You can look at the coefficients for your model. So this would be the actual equation that gets generated by Python, and all the statistical underpinnings. We cover how linear regression works. We discuss, all the statistical assumptions, and you learn all the prerequisite statistics for it. But then you immediately get an opportunity to practice it in Python, and then eventually you make predictions. And we also, for each of these models, we discuss strength, weaknesses, statistical assumptions, all of those kinds of things. But as you go through the entire program, basically, all the examples are presented to you in Python, and you learn all the statistical background, all the mathematical background required for hands-on modeling. But then, as you're learning the theoretical concepts, you immediately get to practice them in Python.
Thank you so much, Dr. Babarchenko. Dr. Babarchenko joins us from the University of Pittsburgh, which was recently named one of Forbes' new IVs. He's a professor in their online or Master's of Data Science, which has been a highly popular degree hosted in partnership with Coursera. This online degree is unique, being that it does not require a data science background, as Dr. Babarchenko mentioned. It welcomes all learners who might be newer to the subject. Also, if you're going to be interested in previewing the program, visit the degree page, click on the request info, and gain access to the free preview course. If you know you're going to be ready for this degree and you have some questions about how to get started, scan the QR code that's going to be on the screen to meet with the enrollment team, or click on the link in the chat.
Okay, for our final demo lesson, we have Professor Rachel Cox from the University of Colorado Boulder to teach a demo lesson on machine learning. Professor Cox is an associate teaching professor in applied mathematics at the University of Colorado Boulder, and her work focuses on teaching foundational and advanced mathematics, integrating computation and algorithms to prepare students for data-driven and STEM careers. So, Professor Cox, whenever you are ready.
Hello, everyone. I am Rachel Cox. Thank you so much for the nice introduction, and thank you for inviting me to this talk. In addition to my teaching background, I also have worked at a satellite technology company. I was part of a machine learning research group that where I developed deep learning models for classification and segmentation of satellite imagery. Now, those images are proprietary. However, I do have some adorable kitten and puppy images to demonstrate the ideas. These images here, since the satellite images are proprietary, I found these adorable images, and they do a good job of demonstrating some of the key machine learning tasks that maybe you are familiar with or are not. But some of the key tasks for image processing are image classification, object detection, and image segmentation. So classification means that you're taking an image and determining what's in the image. So is it a cat? Is it a dog? Object detection is the task of, finding an object within an image. And then image segmentation is actually finding, the pixels that contain a particular object. So you can see that in the last image there, the cat is blue and the dog is yellow. So as a disclaimer, this image in this slide and the next four were acquired from simple Google searches, and they're purely meant as a visual aid for the ideas that I'm trying to convey. And I'm not necessarily endorsing the websites that host these images. I just thought they had excellent images. Next slide, please. Okay, so here is an artist's rendering of a deep neural network. Now, we need a neural network with many layers in order to do complex tasks like input an image and output a classification. And so you can see each layer has several components. There are weights, there are scores, and there are things called an activation function. And then eventually you get to the output. So my idea for this talk today, because machine learning is very complex and we're only discussing it for about 8 minutes, but my idea for the talk is to discuss the mathematics behind a very particular type of activation function called the sigmoid. And in fact, you've already seen the sigmoid demonstrated by the previous 2 talks. It appears with logistic regression. So the way that I will demonstrate how the sigmoid function works is to introduce you to, or to continue to talk about logistic regression, which is a classification method in and of itself. But from this image, I want your takeaway to be that a deep neural network has an input and an output. It has many layers in between. And these layers involve something called an activation function. So for example, an example of an input would be an image of an animal, and then the output is the classification of that particular animal, perhaps as a cat. Next slide, please. Okay, so what is an activation function? Well, here's a nice definition. In artificial neural networks, the activation function of a node is a function that calculates the output of the node based on its individual inputs and their weights. Next slide. So activation functions are critical because in general, they are nonlinear. Without an activation function, if you were simply using a linear model, a neural network would reduce down to a simple linear model and would be unable to capture some of the highly complex patterns that we need to capture in order to be able to take an image and classify it, or take an image and segment it, and so on. So this is a really cool picture that is showing an input image. Okay, so it shows that as the input is sent through the network, as it passes through different layers, there are features and patterns that are discovered in a progressively more complex way. So this figure is showing the input image of a woman. I took this image from AIML.com, and I think it's a great one. But it's showing the input image of a woman. It's showing how lines and edges are some of the first patterns that are detected. And then you see what's labeled as mid-level features. So now we have a sort of this bank of eyes and noses and ears, and the patterns of those. And then finally, more complex facial structures are detected. And then the output is that we're matching this image with a particular person named Sarah. So the takeaway is that a neural network is highly complex, and it's a little bit of a black box, or it can be. Next slide. Okay, so, as we saw a couple slides ago, there are different types of activation functions, and every layer in a neural net contains an activation function. So one type of an activation function is the sigmoid curve. And so the Greek letter sigma is, the Greek version of S. So sigmoid is an S-shaped curve. It is nonlinear. And so this is a lot to unpack, obviously. So we're only going to look at the sigmoid curve today. And this is, again, it's used as an activation function, and it's a means of introducing nonlinearity. And without these nonlinear functions inside of a multi-layer neural net, we would have a simple linear model, which would be unable to capture a lot of the complex patterns that we need to be able to capture. Next slide, please. Okay, so the next group of slides here come from my statistical methods and applications class that I teach here at CU Boulder. And this also ties in with the statistics and Python lessons that we talked about earlier. Underneath the fancy name and fancy mask of machine learning, it's built upon the backs of probability and statistics and mathematics. So here we see a sigmoid curve, and the sigmoid curve is often used for logistic regression. Logistic regression is used as a means of classifying data. So when we look at this image here, we see some blue dots and some orange dots. So those are the actual data points from our data set. And this data comes from the very famous Titanic data set, which you can find, it's widely available on the internet. But essentially, we are trying to look at age as the input to a function or as our feature. And then we're trying to classify based on age whether we would expect a person on the Titanic to have survived the catastrophe or to have died. Next slide, please. Okay, so that curve that is fitting through the data, that's known as the sigmoid curve or the sigmoid function. So the sigmoid function is a type of activation function, and it's also used in logistic regression. Now, it's important to note that logistic regression is a type of classification method in and of itself. All right, just like machine learning can be used for classification tasks, but they're not equivalent. It's important to note that logistic regression is not the same as a neural network, and it's not the same as an activation function. Logistic regression uses the sigmoid, which is also used as an activation function. It's just a very nice way to present the idea and the mechanics behind what an activation function does. So here we have eta representing the input to the sigmoid function, and we have the definition of the sigmoid function, which is 1 divided by 1 plus e to the minus eta. Now, eta is a linear combination of weights and our input variable. Okay, so if our input variable is, say, x is 87 years old, we have some sort of combination of weights, and so the output is a number between 0 and 1, and we interpret that output as essentially a probability. And so if the output is close to 0, we would predict that for that age of person, they would be in class 0. And if the output is a number close to 1, we would predict that the classification for that particular age or data point in general would be class 1. And so there's often a threshold set. 0.5 is a typical threshold, but you can adjust that threshold to anything that you might need. The sigmoid curve can also be customized to fit your data. So by customizing the weights, you can slide that S shape to the left or the right, and you can also sharpen sort of the cutoff that you see or widen it as well. Next slide. Okay, so this just details a little bit more of the thresholding that happens. So the beta naught hat plus the beta 1 hat that you see in that piecewise definition, those are determined by the data that you have. So in the particular example that I gave, that would be, the age ranges of folks who were on the Titanic, along with the recording of whether they died or survived. And then you have this classification of 1 if the sigmoid returns a value greater than 0.5, and 0 if it returns a value of less than 0.5. So this is a sort of a cherry-picked data set that shows a nice fit between the data and the curve. Let's see, next slide, please. Okay, so here's another nice example of a data set that includes more than one input feature. So here we have humidity and temperature as the input features, and then you'll see blue and orange dots. So the blue dots indicate we have data that when the temperature and the humidity were a certain quantity, there was no storm. And the orange dots indicate that when we've recorded a specific temperature and humidity, there was a storm. And so this can also be run through the sigmoid function, and we can get a model that will predict based on different humidity temperature tuples. It'll give us a number between 0 and 1, and we can classify then of whether we would predict that there's no storm or storm. Next slide, please. And so here you see the red area, we would predict a storm, and the blue area, we would predict no storm. And so you can add as many features as you want in this type of way. But once we get past 2 features, it gets a little bit harder to actually visualize. Okay. Is that next slide? Okay. So I just want to sum up, deep learning and machine learning in general is very complex. There's many components. Activation functions, there's many types of activation functions. We've looked at one singular type, the sigmoid curve, and we looked at it within the lens of logistic regression. And this plays nicely because, machine learning, when you peek under the hood, it's really just a lot of probability and statistics. So that's all I have. Thank you so much for listening. I really enjoyed being here.
Thank you so much, Professor Cox. That was fascinating. Professor Cox is professor of the online Master of Data Science degree at the University of Colorado Boulder. This degree is 1 out of 5 that CU Boulder hosts in partnership with Coursera. It's 100% online at just $15,750. This degree is going to be perfect for that working professional looking to level up their career. When talking about the value of higher education in data science, current Boulder student Mike Norton says, you have to stay competitive because as an employee, you get more and more expensive. If you're not upskilling or retooling, you're not going to be relevant. The CU Boulder Master of Data Science program is designed to keep your skills sharp while remaining flexible for the busy adult. Explore performance-based admissions before the October 3rd deadline. And as always, feel free to book a meeting with one of the enrollment team representatives by scanning the QR code or clicking on the link in the chat. Just before we transition to the Q&A with our professors, here's going to be a brief overview of other online data science degrees.
So first up is the Masters in Science in Data Analytics Engineering, which is one of the 3 that Northeastern University offers online in partnership with Coursera. So this top degree does not require a traditional application and instead lets you performance pave the way to admission with the FAST app. So complete your FAST app by 21st of November priority deadline, and you could be eligible to get a 10% new student scholarship for the first semester. Just make sure that you submit your deposit. To learn more, please click in the link that we will share in the chat or register for their upcoming webinar on October the 31st.
Next, we have the Master in Data Science from Ball State. You can enroll in performance-based admissions. There is no formal application required. Simply, you complete 3 courses with a cumulative GPA of 3.0 higher, and you're going to earn admissions into the program. Additionally, Ball Stage program is going to be less than $17,000, and they recognize prior learning credit to potentially save you even more money. Up to 9 credit hours, actually, of prior learning can be applied to this degree program. So click on that link in the chat to learn more about this dynamic and flexible program.
So, known for its affordability and overall value, Illinois Tech offers their Masters of Data Science 100% online for global learners. And with 13 courses in total, there is no formal application for this degree. So simply complete the pathway courses and achieve a B or better, provide your bachelor's degree, and you will be admitted to the program. Illinois Tech also recognizes prior learning credits. So this means that you could be eligible to save up to $2,730 on tuition with prior learning recognition. So if you have already studied in Coursera, this could be a good option for you. To learn more about this program, please click the link in the chat.
We mentioned quite a bit about credit for prior learning today. To get a better understanding of how this works for our degrees, check out the credit for prior learning page that Victoria is going to drop in the chat now. Next, we have the BSc in Data Science from the University of Huddersfield. This is actually one of the only online bachelor's in data science degree available. So if you're just starting out, this could be the program for you. You may secure your place either through the traditional application-based route or by providing your suitability and understanding through their performance-based admissions route. You can build a strong foundations in data science with the University of Huddersfield, ranked in the UK as one of the top young universities by Times. The October 6th deadline is right around the corner, so click in the link in the chat to learn a little bit more.
So finally, we have 2 degrees from our university partners in India. So first up is the PG Diploma in Applied Statistics. This online degree is from the Indian Statistical Institute and has no application fee, and is designed for working professionals looking for a flexible program to be completed in between 1 and 3 years. And last, but certainly not least, we have the Bachelor's of Science in Data Science and Artificial Intelligence from IIT Guwahati, one of India's top engineering institutes. So this bachelor's program can be completed in 4 to 8 years and has a unique focus in artificial intelligence in the curriculum. So to learn more about these degrees, please visit the links in the chat.
All right, so for the last portion of this event today, we'd like to welcome back all the professors to the Q&A session. As a reminder, each professor joining us here today represents one of the top universities that we partner up with to host in their online degree on Coursera. So let's go ahead and get started. We heard a lot about data science skills today. In your opinion, if there's one course that prospective data scientists should take, what would that be? Professor Cox, can we start with you?
Sure. So my opinion is probability and statistics, 100%. Everything, there's new terminology in this field, but when you really look under the hood, it's mostly probability and statistics. It's the heart of so many different models that exist, Bayesian networks, Markov models, logistic regression, other regressions, multiple linear regression. So probability and statistics.
Thank you so much. Anybody else wants to chime in and give us their perspective of any other type of course that they think?
Probability and statistics as probably one of the most core science, but I would also highly recommend learning either Python or R. I personally lean more towards Python because it's also a very good general program, necessarily for data science, so you can use it for other purposes. But learning Python and probability and statistics are kind of like 2 sets of absolutely foundational skills.
Sounds great. Thank you so much, guys. Head it over to Isabel.
Okay, thank you. Now, so let's get some questions that you submitted when you register. So the first one is from Mei Fei from Taiwan. And the question is, what are the subjects and areas someone needs to master in order to become a data scientist or data analyst in a sports industry? So maybe Dr. Barber, can you speak about this and how data science is applicable across many industries?
Yeah, sure. I mean, whatever application you're talking about, as we've just heard, the core probability and statistics underpinning some sort of ability to make a computer do what you want, and some understanding of good modeling techniques or analysis techniques. But then the question about the sports field is good because really what you really want to do is you want to have some domain knowledge. The techniques and methods might be the same, whatever data you're applying them to, but you'll get a lot further if you're working on a problem where you have some understanding of what the data is about in the first place. Whether that's knowing it yourself or being able to work in a team with somebody who's a domain expert. And a lot of the best projects, I think, have always been around groups of people who are bringing different perspectives.
Great, thank you for that. So I'll hand it to Ruben for
Correct.
the next question.
Thank you so much, Isabel. So our next question comes from Benjamin in Texas. As a beginner in Python, I have been vibe coding. Can I rely on this to create MVPs of my ideas, in your opinion? Dr. Babarchenko, maybe you want to take a stab at that?
As a beginner, I would advise heavily against vibe coding. So the problem with over relying on LLMs to generate code, especially as you're starting out, is that a lot of times LLMs take shortcuts and you don't necessarily understand what those shortcuts do and why they're there in the first place. And without understanding why things work and how things work, and kind of treating, and I see the same problem with people treating statistical models as black boxes. You have to have some foundational understanding. Otherwise, it becomes much more difficult moving forward to generalize your solutions to different domains and you're doing, et cetera, et cetera. So while I have no problem with vibe coding when you're more experienced, at the phase when you're learning foundational skills, I honestly think it's not a great idea.
Thank you.
Thank you, Dr. Babichenko. So I'll take the next one. And this one comes from Elizabeth from New York. So how do you approach teaching students to evaluate the ethical implications of their data science work, especially around bias? So Dr. Sexton, can I hand this one to you?
Yeah, sure. Well, this is just really important that you just really start at the beginning and examine in detail the data that you've got. Where did that come from? Who collected it? What do we need to remove as part of the modeling process? Are we doing anything to this data that's accidentally creating features in there or removing groups of people that are going to invalidate our analysis? And I think you've really got to come to it early and continuously and just be really curious about the assumptions that you're making all of the way through the process. And that's embedded in our program, both in individual units and in the project skills and the projects that I'm teaching to really look at, where's your data come from, who created it, why, and making sure that, if you're using something secondary, that you've got the same intentions as the original collectors.
We are going to ask the last question. So for learners who might be interested in applying for a degree program, what is one piece of advice that you will give them? Maybe something about the application process or words of wisdom about career path.
Well, I would say, determine what your passion is. And if, once you've decided what you want to study, then start thinking about the components and tools that you'll need. So for example, if you're really interested in biology, then there's biology data available out there. So you'll want to start thinking about, okay, if I want to digest this biology data, what do I need? And it's likely going to be, well, I need to understand Python. I need to have a basic understanding of statistics and probability, whatever it is, break it down into the small components and then choose the degree program that fits with, what you need.
Thank you so much for that. So one more big thank you to all the university representatives that we have joining us today. So just a reminder that all these programs are actively recruiting for the next cohort and are eager to review your application. So please do submit your application if you are interested.
Well, thank you so much, guys, for being here. Also, the professors, everybody for taking time out of the busy schedule. If you are wanting to get more information, we encourage you to visit our degree pages to learn more about how you can take the next steps in the data science career. Don't forget to get in touch with the enrollment team by booking a meeting. Thank you so much and have a great rest of your day. Take care. Bye-bye.